Hey students, this is lesson 10.4, perimeters and areas of similar figures. In this lesson, we're going to learn how to find the perimeters and areas of similar polygons. All right, go ahead and do the vocab here, and I'll check back with you with the answers. All right, Theorem 10.7, a main theorem we're going to use in this lesson, is that if the scale factor of two similar figures is a over b, then the ratio of their perimeters is the same, a over b, and the ratio of their areas is a squared over b squared. Go ahead and think about that and fill in the answers to 8 through 12. Okay. On problem 1, we're going to use that theorem. If the rectangles below are similar, the ratio of the lengths of the corresponding sides is 6/8 or 3/4. That means the scale factor is 3/4. Okay, and by that theorem 10.7, we know that the ratio of the perimeters will be the same as the scale factor. So the ratio of smaller to larger the perimeters will also be 3/4. And we know that the ratio of the smaller to the larger the areas will be the scale factor squared. So we'll just do 3 squared over 4 squared, which equals 9 over 16. All right, you try that. All right, in problem 2, we're going to apply that concept here to try and find another area. So we know that that these two polygons here, these two hexagons, are similar. That tells us that we have a scale factor between them, and the scale factor will be 7 over 10. So the ratio of the areas should be that scale factor squared, which is 7 squared over 10 squared, which is 49 over 100. And we know that the smaller hexagon has an area of about 127.3. So the larger hexagon should be, we should be able to find that using this ratio of the areas, which is 49 over 100, and we'll just place the area of the smaller square with the smaller of the numbers in this ratio, which is 127.3. And then we'll find the other area. We'll just call that x for now. And we're going to use the cross product property to figure this out. So we get 49 times x is equal to 127.3 times 100. And then we're just going to divide both sides by 49. And we get x is about 259.8 square feet. All right, you try that. All right, here's another problem that deals with areas. And that's because it's carpeting, and carpeting is covering a floor, so that's an area. It says it will cost Maria $150 to have carpet installed in a room that is 12 by 10. At this rate, how much would it cost her to have carpet installed in a similar shaped family room with a larger dimension of 18 feet? So we're going to use scale factor to do this. There's actually other ways to solve this problem, but let's find the scale factor. The scale factor is 12 to 18, since those are both corresponding sides. 12 over 18, which we can simplify to 2/3. Okay, so that means the ratio of the areas will be those numbers squared. So 2 squared over 3 squared, which is 4/9. And since carpeting is area, and we know it costs 150 for the smaller room, we can just write a proportion using the ratio of the areas and put the cost of the smaller room with 4 in your proportion. Put that over x, and then we're just going to use cross product property. 4 times x is equal to 9 times 150. So x is equal to 9 times 150 divided by 4, which is 337.5. So it should cost proportionally $337.50 to carpet the larger room. All right, you try that. All right, in this last problem, we are going to find ratios of perimeters. It says the area of two similar figures are 42 and 50. What is the scale factor? So the scale factor, or the ratio of the areas, would equal 32 over 50. And remember the relationship between the areas and the scale factor. That would be our a squared over b squared. So if I just take the square root of both sides, if I take the square root of a squared over b squared, the principal square root, I get a over b. And so if I take the square root of 32 over 50, that should equal my ratio of a over b. And I'm just going to simplify that ratio. So a over b is equal to the square root of 32 over 50, and using my property of square roots, that quotient 32 over 50 can be split up and it's done separately. And, or else I could just simplify the fraction 32 over 50 first. Maybe we'll do that. I think I can for sure factor out 2 out of both of those, and that gives me 16 over 25. Then I can take the square root of the numerator and denominator separately. And the square root of 16 is 4, the square root of 25 is 5. So the scale factor between these two similar figures is 4/5. All right, you try that. All right, we're up to the lesson check. Go ahead and do that, and we'll talk about it next time we meet in class.